In this video, we're going to talk about the schema-on-write approach to collecting and storing data. If you want to learn about schema-on-read approach, please see our other video on schema-on-read and big data. The schema-on-write approach is the traditional approach to creating databases that we'll use in this class. Schema just means the way the data is modeled. So in a schema-on-write database, we have to set up the way we want the data to be presented inside the database before we start recording and capturing data. This means that we have to know what data we want on the back end before we design the database on the front end. This requires a lot of information from end users, because think about it, if you wanted to set up a database for a company, you would want to know what people in your marketing department and people in your HR department and people in manufacturing and people in sales, what data do they need to do their job? And we need to set up our database in a way that they can get what they need on the back end. So it requires a lot of upfront conversations with people from various departments about what they need and how they want their data to be recorded. So it's a little more difficult on the front end than a schema-on-write database, but it becomes very useful. In this class, we're going to talk about schema-on-write databases that are of a relational database variety. So this just tells us that, like I said, end users should provide the input for the database design. So think about all the people in your organization that you would talk to if you were building this database. There are 3 steps to building a schema-on-write database. The first is to map the reality of the business. What I mean by map the reality of the business is, as you are buying and selling things in your order to cash and your procure to pay process, you want to be able to capture data about what actually happens. That's what we mean by mapping reality. I don't want to map what a process should be. I want to map what it actually is. So I want to take all the things that happen in our order to cash, our procure to pay, and all of our other business processes and capture them in this relational data model. So after I've mapped this reality, I map it into what's called a conceptual model, or an ER diagram, an entity relationship diagram. So we'll see one of those going forward, and we'll have an additional video that explains in detail this entity relationship diagram. So if you become confused when we're looking at it, please see our other video on this ERD. After we create this conceptual model, which again maps the reality of our business into a graphical form, we take that and we turn it into what's called a logical model. A logical model will tell us what tables we need in our database and what keys we have that will link our tables together. So basically we'll take this entity relationship diagram, this conceptual model, and it will turn it into rows and columns and into tables so that we can relate all of our information to all of our other information. That sounds complicated, but as we walk through it, it'll become more clear. The third step is to create the physical database using database management software. We will use the database management software Access, Microsoft Access, in this class as we work on this relational model of the BA342 business, but more on that later. Here is the ERD, or the entity relationship diagram, that I spoke about a minute ago. This is the conceptual model of our BA342 business. As you can see, these boxes, or these rectangles, represent entities. The entities are things that we want to collect data about. So they can be people, like employees or customers, or suppliers or shippers, or they can be the things that we're trying to sell, such as products. Our products in our database are put into categories such as beverages or food or things like that. Other entities on our diagram, like order and sale, are transactions that we want to record things about. From class, you'll notice that there are master files in this ERD, and there are transaction files in this ERD as well. The other part of an entity relationship diagram, besides the entities, is the relationships. You'll notice the relationships are the lines that connect the entities in this ERD. More on that in another video and how to read these entity relationship diagrams. But just one example here. We have customers that place orders with us in BA342 Company. So each customer can create many orders. So the way that I figure that out is I say, put my finger or my cursor or whatever on this customer entity, and I say, if I pick out any one customer at random, how many orders can they have? At a maximum, and that's what this many cardinality is. One customer may have many orders. to read it the other way, how many orders, if I take one order individually, how many customers does that relate to? It relates to one and only one customer. Again, more on that in a related video, so if you need more help with this entity relationship diagram or just more detail, please see our other video. This is also part of the conceptual model in this way that we're designing this Schema-on-write database. You'll notice that these rectangles appear again, and you'll notice category, customer, employee, order, product, sales, shipper, and supplier. The same entities that you see on our ERD are then just transferred down here. And what's happening in this slide is that we have taken the entities and decided what we need to know about them. So for customer, for example, we have the unique identifier, the customer ID. We have customer first name, customer last name, birthday, income bracket, address, and all of the things thereof, phone and fax. So that's all the data that our end users have told us we want to capture about this entity called customer. And it's the same for each one. Please note again that the same entities that appear on this page of our conceptual model with all of our attributes are the same entities that appear in this ERD. These attributes are just simply data, again, that we want to collect about these specific entities. After we have created that conceptual model and listed the entities here, we'll move to stage 2, where we turn the conceptual model into a logical model or the database blueprint. Again, this note here to say there are other logical models, but this is the one that we're going to use, this relational model, in this class. So a relational model is built using the conceptual model by linking tables together. So one way that we link tables together is creating duplicate fields in the tables we want to link. So for example, we will put the customer ID from the customer table in the order table. I'm going to go back just a minute to tell you the customer ID is going to be this identifier in this customer table, and we're going to put it into the order table because we want to know which customer has ordered something. That's called creating a logical model. It's the way that we link fields together with this data duplication. Another way that we link tables in a relational model database is by taking any many-to-many relationship and creating a new table. Forgive me while I go backwards for a second. What I mean by a many-to-many relationship is a relationship here, like between product and order. So if I have one particular sales order, I can have many products on that order. If I take one particular product, I can have many orders for that one particular product. So this is called a many-to-many relationship. Just as a side note, this relationship here between order and employee is called a one-to-many, and we also have one-to-one relationships. But any place on this diagram that we have a many-to-many relationship, we're going to have to create a new table. More on that later and in another video, but just for now, know that we have to create a new entity for any relationship which is many-to-many, which is what is happening right here. Again, more on that to come. So after we have decided what tables we need, so one for each entity and one for each many-to-many relationships, we create this logical model, which tells us the table names, instead of being in boxes, now they're underlined. So these are all the tables that we have. So you'll note that we have 10 tables now. We only had 8 entities originally, but again, for the many-to-many relationships, we've added the sales line table and we've added the order lines table to compensate for those many-to-many relationships. So now we have 10 tables in our database. You'll notice each bold ID here is called a primary key, and it's what identifies that table. So each record in the table, so employee ID, for example, would be like your student ID. So your student ID, or in this case employee ID, is what distinguishes you from other students. It isn't your last name, it isn't your first name, it isn't even your address because you have roommates. So we create the student ID or this employee ID to keep each record unique. So we have one of those for each table. You'll also notice in this order line and the sales line table, we have what's called a composite primary key. There are 2 parts to these product IDs. Again, more on that later, but just wanted you to notice for now. So now we have each table and we have the primary key for each table. But now we have to notice something else. This employee ID, employees are related to orders and they're related to sales. So we're like, we think, how do I relate these tables together? Because I know if I go back, I know that employee is related to sales because it has a relationship. And I know that it's related to sales. Sorry, the other one was orders. I know it's related to sales because it's has a relationship. So how do I relate those things together? Well, I do that by posting what's called a foreign key in the orders table and the sales table. So I will take the employee ID from there, employee ID, and I will post it in the sales table so that I can tell which employee placed a sale or which employee has recorded an order. Hopefully that makes sense, but all of these italicized are foreign keys, and you'll notice if you look that all of the foreign keys are primary keys from another table, and they just represent how the tables are linked together. After we create the logical model and decide what happens in our database and how all of our tables are going to be linked together, we move to stage 3, where we physically create the database in database management software. So in our case, we're going to be using Access, and we will get to that after exam 1, but just be aware that that's where we're going and why we've written all of these things down. I wanted to point out this slide to you. This is just a picture of what happens in the database and how all of these things are linked. Please note that there's no need to memorize this. This will be provided to you on many occasions, and you shouldn't spend time memorizing it, but you do need to figure out how it all works together. So a moment ago, we were discussing how employees are related to sales and they're related to orders. So again, we have this primary key of employee ID in the employee field, and we see that that employee ID is a foreign key in the orders and in the sales table. We know that it's a foreign key because it is circled, but you'll note the primary keys have all of these like lovely little key things beside them. So this is a picture that just graphically tells you what attributes are collected about each entity, how the entities are related, what the primary keys are and the foreign keys. And again, more on this at a later date, but this sales line and this order lines table, these are composite keys for this table where we have 2 primary keys that must be listed together in order for us to access these records. I hope that this has cleared up some of the Schema-on-write difficult concepts and how we build databases in a Schema-on-write database. Thanks for watching, and please see our other videos.